Hi everyone and welcome to today's second lesson on topic B4 Bioenergetics. Today's lesson is on limiting factors of photosynthesis. You will need a pen and some paper to complete today's lesson, so if you do not have them in front of you, please pause the video and find them now. Today's challenge is to be able to describe how the limiting factors can affect photosynthesis, and today's Aspire is explain the inverse square law in the context of photosynthesis. So today's starter, I would like you to write me down the word equation for photosynthesis, and the extension task, I would like you to write down the balanced symbol equation for this reaction also. So I'm going to give you 3 minutes to do this. Off you go. So the answer that you should have written down, the word equation for photosynthesis is carbon dioxide plus water in the presence of light energy gives glucose plus oxygen. And the balanced symbol equation is 6CO2 plus 6H2O gives C6H12O6 plus 6O2. Okay guys, so there are 4 factors that can affect the rate of photosynthesis. I would like you to have a go at writing down what you think these are. If you are struggling, just have a look at the equation that you've just written down for photosynthesis and see if you can come up with some ideas. So I'm going to give you a minute to write down these factors. Off you go. So the factors that affect the rate of photosynthesis is carbon dioxide concentration, temperature, light intensity, and the amount of chlorophyll. Something to mention now as well, that limiting factors are very important in terms of the economics of greenhouses, and what I mean by that is gardeners or farmers that are growing certain things that they want to sell to the general public. Limiting factors of photosynthesis are really important because what they want to try and do is maintain the maximum rate of photosynthesis but still obviously make a profit on their things that they're growing to sell. So the first limiting factor that I'd like to talk to you about today is light. And if you look at the graph on the right hand side, you can see that the more light there is, the faster the rate of photosynthesis. So obviously this means that the rate of photosynthesis will depend on the amount of light. So at this point in time, light is the limiting factor. Then after a certain point, you can see that the graph flattens out. And so photosynthesis at this point will go any faster, even if you increase the light intensity. This is because at this point, light is no longer the limiting factor. It is now either temperature or carbon dioxide concentration that would be the limiting factor. So you've just seen the graph for how light intensity affects the rate of photosynthesis. So what I would like you to do now is I'd like you to sketch that graph, and I'd also like you to have a go at sketching what you think the graphs would look like for carbon dioxide concentration and temperature, and how the rate of photosynthesis is affected by these. So I'm going to give you 3 minutes to do this. Off you go. So these are the answers that you should have. So as light intensity increases, so does the rate of photosynthesis up until a point, and at the point where the graph flattens out, light intensity is no longer the limiting factor. The limiting factor is either carbon dioxide or temperature. Then the next graph that you should have sketched out is very similar to the light intensity one. So as carbon dioxide concentration increases, so does the rate of photosynthesis up until a point where the graph flattens out. At this point, carbon dioxide is no longer the limiting factor of photosynthesis, and either temperature or light intensity are the limiting factors. And then the last graph is very, very different from the other graphs, and this is the rate of photosynthesis against temperature. All I'm just going to do is describe this to you, because the next task that I'm going to ask you to do is for you to think why this might be. So we can see that as temperature increases, so does the rate of photosynthesis up until a point, and then at that point then the rate of photosynthesis dramatically decreases with temperature. So like I said, the next slide will actually be a task on this. So why does the limiting factor graph for temperature have this shape? I want you to think about what you know about enzymes and temperature, and I would like you to write down your ideas. I'm going to give you a minute to do so. Off you go. So the answer to the question, why does the limiting factor graph for temperature have this shape? It has this shape because, as you can see, as temperature increases, the rate of photosynthesis will increase to a point, and then you'll see that then the rate of photosynthesis decreases after this point. That is the point at which enzymes will denature. And when enzymes denature, it means that the reaction of photosynthesis no longer occurs. So that's why the limiting factor graph for temperature has this shape. Okay, so now we're going to have some exam question practice, and this is a graph of percentage of carbon dioxide concentration against percentage concentration of oxygen after 5 hours in low light intensity and high light intensity. So the question is, and this is a 2-mark question, so I'm going to give you 2 minutes to complete this. Describe the effect of increasing carbon dioxide concentration on the rate of photosynthesis at low light intensity. Now, with a lot of data questions that you will have on your GCSE exam, you must include numbers as part of your answer. So you need to read numbers off the graph and include them as part of your answer. So you have 2 minutes, off you go. Okay guys, so the answer to the question, describe the effects of increasing carbon dioxide concentration on the rate of photosynthesis at low light intensity, is, as you can see from the graph, it increases and then levels off. You will get 1 mark for saying that. And it levels off up to 0.15% CO2 concentration. So then the second part to this question is to explain the effects that you have described. So in your answer, you need to refer to limiting factors. So explain the effects you have just described, and in your answer, you should refer to limiting factors. So I'm going to give you 2 minutes again to explain this. Off you go. Okay, so the answer to the question, explain the effect you have described, and in your answer you should refer to limiting factors. So in this question, carbon dioxide is the limiting factor at first, and then when the graph goes flat, light then is the limiting factor at the end. So these next coming slides are higher tier only. So if you are a foundation tier student, you just need to go to the end of the PowerPoint and please just copy down the summary notes. If you're a higher tier candidate, please then just carry on doing these slides. So higher tier only content for limiting factors of photosynthesis is the inverse square law. So the inverse square law links light intensity and distance. So you can see that as distance increases, the light intensity decreases. So to be more specific, light intensity obeys an inverse square law. This means that if you double the distance, you will quarter the intensity. Okay, so we can use an equation to be able to calculate light intensity. So light intensity is proportional to the 1 over the distance squared. So the inverse square law, the 1 over is showing the inverse part, and obviously its distance squared is showing you the squared part of this equation. So now we'll have some exam question practice. So L is light intensity and D is the distance of the pondweed from a light source. The student placed the pondweed at 5, 10 and 20 centimeters from the light source. Explain how the light intensity will change as the distance of the pondweed from the light source is doubled. So you must include calculations in your answer. So I'm going to give you 3 minutes to do these calculations. Off you go. Okay guys, so the first distance was 5 centimeters. So obviously the equation L is proportional to 1 over d squared, so 1 over distance squared. So we need to square the distance to start with. So 5 squared is 25, and then you do 1 divided by 25, which is 0.04. Then the next distance was 10 centimeters. So again, to square it, which is 100, 1 divided by 100 is 0.01. And then the last distance was 20 centimeters. So again, we square it, that gives us 400. And 1 divided by 400 is 0.0025. So you get 1 mark for doing the squared part. The second mark comes for doing the 1 over d squared calculation. And then the third mark, and this is something that I just really need to point out now, whenever you've got a question on your exam about inverse square law, you need to say exactly what's happening. So as you can see, as the distance doubles, the light intensity has quartered. Okay, so this is another higher tier part only. How could we maximise the growth of plants? What could we do, or what could we use? So I'm going to give you 3 minutes to think about this and write down your answers. So what could we do to maximise growth of plants? What could we do, or what could we use? So 3 minutes, off you go. Okay, so the things that you could do to improve the growth of plants is to use a greenhouse. You could use an artificial light so that photosynthesis can occur beyond daylight hours, or use a paraffin lamp, and this increases the rate of photosynthesis because the burning of paraffin produces carbon dioxide and heat too. Okay, so now we've come to the end of today's lesson. As always, I would like you to copy today's summary notes for this lesson. I'm going to give you 5 minutes to do so once I've read them out to you. If you need longer than that, please make sure that you pause the video and complete them. So, light, temperature, chlorophyll and carbon dioxide are all limiting factors of photosynthesis. As light intensity increases, the rate of photosynthesis increases until it levels off due to another limiting factor, temperature or carbon dioxide concentration. As carbon dioxide concentration increases, the rate of photosynthesis increases until it levels off due to another limiting factor, which is temperature or light intensity. As temperature increases, the rate of photosynthesis increases. However, if it gets too hot, the enzymes will denature and this decreases photosynthesis. Limiting factors are important in the economics of greenhouses, so we can try to gain the maximum rate of photosynthesis while still maintaining a profit. And for higher tier students only, the inverse square law links light intensity and distance. This means that if you double the distance, you will quarter the intensity. So you have 5 minutes to copy down these notes. Off you go.